Hello, how are you doing, Jarrell and Ghislaine? Okay, so we are going to cover Onion Router today. Let me get on Zoom on my other system too. I'm going to go ahead and share screen. So if you can please check out your notes and your assignment. Okay, good to know that you're doing well. Okay, so today we are going to talk about chapter 5, which goes over onion routers. And in the lab, we are going to use Python module to use it. But in this assignment, we're mostly going to address concept. And also we are going to install onion router on your Linux machine. So if you have Cali Linux or Ubuntu, you can use that. Okay. I'm gonna log into my other system just in case that I need to run and if it's not responding on my laptop. Okay, so in chapter 5, it starts with talking about what TOR is, and some of you might be familiar with this.
Recording in progress.
So TOR is it's a little echoey. TOR is the onion router, and we would use this for to be able to access the dark web or even research some of the tools. Let me get out of this because it's gonna be a little echoey. So here in the beginning of the unit 5 notes, it talks about what TOR is. And so in order to use TOR, you have to use TOR browser, or you would be installing the package on your Linux in order to do that. So when you access it, it creates a virtual tunnel that's going to shield because it's using encryption to be able to route all your packets from the destination, from the source, which is your client system, to the URL that you're accessing. And in the TOR network, you cannot access those HTTP or web server without having to go through the browser itself or the service that you would install on your Linux system. So now onion routing encrypts browsing traffic. So all your packets are going to be encrypted along with the instructions. And it passes from node to node, and every level that it passes, it encrypts. So that way, the node doesn't really see you. The only node that actually see the web server is the exit node, which is at the end. So when you connect, it uses virtual circuits, and these virtual circuits are established to be a network. That's what we know as TOR. So you can use it for anonymous browsing. You would be able to also implement proxy, but in proxy, because the proxy is the middle entity, it actually is able to track and collect data. So in the VPN environment, a lot of the times it, between you and the VPN service provider, they can actually see your traffic compared to the onion router. So the onion router, because it uses encryption, if somebody is listening or monitoring your traffic, they will not be able to analyze your traffic as it is encrypted traffic. And it goes from node to node, like we said. So let's take a look at some of the process that it needs to go through. So when you use Tor, first you need to use the browser, of course, or you have to install the package on your system. Then you would be able to connect to the Tor network using the browser. Now, the first thing that you're going to see is you are going to see a guard node. So this is going to be a node or a system that's going to give you the directory of all the other nodes. Now, the nodes changes over time, so it will frequently change. So even if you establish that right down the line, it will not be the same. So no traffic is going to be relayed the same way. And that's what's cool about the Tor router, the TOR. So you're going to have three elements. That's going to be your guard node. That's the beginning node. That's going to connect with the client. And then you will have at least one middle node or relay nodes. In some cases, you might have up to 5 or 4 additional relay nodes. So think of it as that it's going to pass from one system to the next system until it gets to the exit node. And the exit node, its job is to really decrypt your requests from the client and be able to see who is the HTTP server. And so that's it's going to serve that it's going to send that request to the server, and the server is going to respond back, and then so therefore it's going to go back all the way back to you through the encryption and the tunneling. So in the first question, it asks you, describe the purpose of the onion router. And you can create this onion router using a Raspberry Pi. You can use your Linux system to access the Tor network. But basically, you have to use an application or the package to access it. So in network security, Tor really hides the location of the user when they're accessing the web, especially the dark web. And it would encrypt the browsing traffic by mixing with the other traffic. And so therefore, like an onion, there's different layers to the onion. So as it moves from one node to the other, you would see that it encrypts and double encrypt, or in even some cases, so it would increasingly encrypt the packet or the traffic as it passes along. Now that would allow you to hide the IP address of the visited website. So therefore your browsing history is not recorded, right? So when your session ends, it removes that browsing information. So if you want to surf anonymously or visit the web anonymously, Tor is a good option. And from the DNS side, because DNS stands for domain name system, right? It resolves IP to the domain information. It uses the service to really protect how you're accessing the DNS and the HTTP server, because all HTTP server ties with the domain name system to be able to resolve the IP to the domain. So with that, you would not have history of the DNS that you visited or the web browser or the web server that you visited. So the things that I've listed, you can also find that on the first page of your notes, and it describes the purpose of the onion router. Any question? Also included in the first part of the notes, it talks about the process, and the process will later break down into more details, but just to really summarize it, the client would need to first obtain a list of relays, and these are nodes that are going to be able to pass the traffic as they encrypt them. And so, and at least we would see from the client standpoint that it would require 3 nodes. The first is going to be the guard node. That's going to be able to give it the directory that it needs for all the other nodes. So this guard node contain the public map of what the relay nodes would be. And it would randomly gives the node information to the client. So it would not be matching if you're another client. And then you would have at least one middle or the relay node. So this is going to be passing along the traffic. And then the third element that we would acquire at the beginning is going to be the exit node. And this node is used for decrypting your requests. So when the information is sent through the network, it is encrypted, and only the exit relay, which is the last node, can see what website you are requesting. And therefore, it would have visibility with your data through the network packets that were sent to this web server. So the identity of the packets, however, are not known because it would not be able to identify your IP address as a client who's requesting. It can only see the destination server. So it would see the endpoint URL. It would see the data in the packets as it decrypts that to be able to send that to your HTTP server that you're accessing. So as the OneGuard node provides the directory list, it encrypts the packet or the message. Then it will pass it on to the middle or the relay node. And this node is then further encrypted. So it double encrypts. And it would be able to send that to other relay nodes and eventually the exit node. So not only that you have one layer of encryption, you actually have at least two or more layers of encryption. So as is noted in the text that after it doubly encrypted, the guard relay would then be able to see who is the middle relay. So the only way that it can see who's next to it is that if it's passing that traffic on to the next relay. So after the guard node, which is your first node, that node is able to see the relay node, the middle. Okay. But the relay node cannot see you because, again, the traffic is encrypted and your IP is not going to be passed. So the only IP that it sees is going to be between that, the relay node and the guard node. Any question in the process? So you can find this on the first page of the notes as well. So as we mentioned, some of the job here, we can summarize it. So in the TOR route, you would see these entities are at work. So the function for the guard, the middle relay, and the exit nodes, the guard relay encrypts the encrypted packet from the client and the instruction so that way it can send it to the middle relay. It also provides the client machine with the directory of all the other nodes, the public map of it. Then the middle relay encrypts the message again and the instruction and send it to the exit node. And when the client encrypts the packet at the beginning, it actually used the public key of the exit node. So that way the exit node can decrypt the packet and forward it to your web server. So what you're using is you're using these nodes to be able to encrypt the traffic. And as we use encryption, encryption requires resources and time, right? So time is part of the resource. So processing power, hardware resources, and then in the communication, you would have these circuits the virtual circuits that's established in order to create this TOR network. Now, at the beginning, we said that the guard relay provides the directory of all the nodes that are publicly recorded, but it's randomly given the client a certain node, and it doesn't always have to be the same. So it's going to be different for every client. So therefore, when you review the notes, it talks about how, because these notes are randomly generated, right, we would see that the traffic pattern would not be the same. So if somebody's trying to scan someone, because of the encrypted packets, they will not be able to sniff out your traffic information. And as each node would not know the destination until it gets to the exit. So only the exit node would know what the destination would be, but it would not know what the source would be. So you would not have the entire information if you scan as an attacker. So therefore, it's really hard to track someone using TOR, and because all of these information is passed as encryption. And so this is a way for many illegal sites to be able to be established in the TOR, in that it's harder to track who's visiting those sites and what type of resource they're using on that site. Any question? So in the notes, it further breaks down to the more details. So I'll show you. Okay. So here it depicts it, and I put in the link for TOR projects. So if you want, you can also view the videos. And to download TOR, there's a separate link, and you can do it straight from command line. And then you can also view the GitHub information, and the overview actually contains the explanation of what TOR is, and they have graphic information like videos you can see. So really the step-by-step process, the author gives you the breakdown here, and I put it again on the notes for you. So as we mentioned, so the type of encryption it uses is going to be the asymmetric encryption. So it uses the key pair. You have the public and the private key. And in the case if it uses RSA, right, you would see that it would encrypt with the public key and then decrypt with the private key. So even if the key is captured, people won't be able to access or decrypt the information. And note that all the nodes are chosen randomly, so they won't be used twice. And also TOR also update the nodes frequently. Okay. So to really avoid any kind of analysis from someone looking at the traffic and looking at the nodes and how those nodes pass the traffic, every 10 minutes TOR connection nodes are changed. So because they have so many in the network, you would see that it would be when you randomly generate that, you would have different combinations of routes, so you won't have the same routes. Okay, so if I'm requesting a web service, a hidden service from a certain web server on TOR, the second time I do it, it would not be the same. So when someone scanned me, the only thing that they can visibly see is how the adjacent node would be. And that adjacent node would see the next node and so on. And so they won't have the entire information of my request and the server response. As we have done some programming with this with Python, and you can see that you can actually look at headers, right? So it is not transparent as what you see in your normal HTTP service. In our case, using the regular web browser and so on. So the source system, which is the client system, right? When it connects to the first node, which is your GAR, it sends the packet to the node. And it would decrypt the packet and follow the instructions. So the guard would take that packet, decrypts it, follow the instruction, and then encrypt it again to send it to the next node. So even if they capture my key at the guard node, they would not be able to get the information once that guard node has sent. And so when the next node receives it, it decrypts it, and then it looks at the instruction, and then it encrypts it again. And it would do that until the data gets to the destination. Okay. And in the instruction simply is which path it's going to send, which node it's going to be next. Okay. And that comes from the directory that we established at the beginning. So it maps out, right, randomly pulling those nodes to put together a route path. And from there, what it's going to do is as every node receives your packet, it decrypts, right? Look at the information or the instruction on how to pass it to the next hop, and then it's going to encrypt it and pass it. So in the sending, in the transmission, your data will be encrypted. Okay, so running Wireshark and scanner on it will not be effective. So here it talks about TOR protocol as multiplexing circuits. And so over a single node to node TLS connection. So because TLS uses stream-based encryption, right, it would then piggyback on TLS to be able to submit the traffic. So each of your circuit path for each of the node would then be established at the beginning with the client. Okay. So the TOR routes the traffic using the guard, the relay, and the exit. Those are the three main components on the route for TOR routing. And in that, it uses what's called the flow multiplexing, where each of the circuit can transport multiple TCP connections. So in the past, when we're looking at your regular traffic, you would have a TCP connection that's established between the client and the server, and it has to acknowledge that connection. Well, unlike your regular TCP connection, we're able to achieve multiple TCP connections with TOR on a single circuit instead of one-to-one. So each node would only know the source and the destination pair circuits, not the entire route. So it will not know where that's going to end up going, right? It's only going to go from node to node as a pair circuit. And so this will shield the identity of the system that's accessing or that's requesting along with the system that's serving. And using that, we would see what TOR has as hidden services, all of these sites that could be for illegal type of services and so on. Okay, because it's harder to track. And so TOR allows website to hide IPs, ports information, and so on. So there are specific ports that it's using, and you're going to see that in when we install the router and look at the config file. And compared to the author's note, which is when he wrote the text, he looked at the statistic, and it's about 60,000 active hidden services. But if you visit the link that I provide here, you would see that it has dropped down quite a bit. So by 2022 of March, right, we're looking at it peaking at about close to 25 to 30,000, maybe 25,000 here. Okay. And then, you know, periodically drop off and then sometime peak again. But at the height of it, you would see that it's above 60,000. So these are 60,000 different sites that exist in the TOR. Okay. Now for us, we would see that it will peak about 25, close to 30,000. Okay. And so you can take a look at, you know, the type of services, and then if you click on the server, it also gives you the number of relays. Okay. And then, so it gathers some of this information from node to node there. Now, the bandwidth in TOR is strong, right? It's good bandwidth, so that it's able to establish the connection this way. But like anything that you would use with encryption, you would see that you would suffer from performance compared to your regular router. So not everything that we want to use is through TOR. So TOR is specific to the network, right? The resources that we want to access to look at hidden services. So in the case where we would look at things like data that were leaked that would be exchanged, that will be in the dark web, and so we would use TOR. Or when you know, when you're investigating a certain things, you might need to access that, right? Because as dark web would store things like, you know, drug trafficking and a lot of even human trafficking sometimes, right? You know, hired killers and so on. So there are many illegal services that happens in the dark web, and because visiting the dark web, a lot of the individuals would want to hide their identity, so they would use TOR. Any question? So statistically, we would see that we have hidden services like those sites that are listed on the statistic webpage. But we also know that because of the performance, using those circuits can cost. And so between the clients and the server, you would see that there is performance lag there. There would be 6 nodes between the user and the service provider. So when we do trace route in the regular traffic, when we're following the traffic from your system, which is the client, to a server, like a web server like google.com, to that domain, you often, when you follow the traffic, you would see that there would be at least 30 hops in the process. So it has to leave your internet service provider network and go across to other networks and eventually reach Google domain. Now in TOR, what you would see is you would have the 3 main elements, which is your guard, your middle, and your exit, along with the relays that's in the middle to be able to pass on the traffic. Okay. And because of performance and the requirement in establishing these circuits, you would see that the sites that are being provided through TOR is going to be simple or lightweight, as you don't see that compared to our regular web-based environment in a normal sense. Okay, so in a normal internet, you would see that we would have things like web applications, a little bit more interactions and how we would utilize that site. In TOR, those sites tend to be informational sites, or to be able to exchange some information quickly. And so it would be more simplistic. So to connect to the TOR network, as I mentioned, you would use the TOR browser. It is a mock of your Firefox. In that, it has some features and some options. So you have TOR button, you would have a no script, and then you can have HTTP everywhere. So these are the options where it would be able to send you to you can access a certain location by using those features. And you can use the configuration file to obtain information about different routes and different servers that you can connect to automatically. Now, the browsing history, it's only going to last until the session ends. So it automatically gets deleted once you end that session. So once you connect it to a site, which is called a hidden service, then once you use that service and you end the session, it removes your history file. Okay. So the browser is really designed different than what you would see in a normal browser. So you would use the package or the browser bundle. In a regular system, we would download it and then we would unzip it. You can download it and do everything in terminal in Linux. Okay. Now to start, you would run the script, and that's gonna allow you to access the unzipped directory and be able to launch a service. So in Debian Linux, like your Ubuntu or Cali or Mint, you can do sudo apt install tor browser -launcher, and that's going to bring in the tor browser launcher package. Once it's already downloaded and installed, then you would call on the browser by using the tor browser launcher command. And if you look at Cali documentation, they show the same thing. Okay. Now, once you're connected in TOR, you can use a link, which is check.torproject.org, to be able to see your status. Okay. Now, this is, if you visit this link using your regular browser, it will tell you that you're not using a TOR browser. So it only works to provide you status using your TOR browser. Now, some of the feature that it gives you is that you can browse using different IP addresses and it can be changed dynamically. So that way it cannot be traced. So IP will last as long as it's passed throughout the TOR. Okay. So the IP will be, sorry, I missed the word B here. It would include the information for the last router that was passed in the TOR. So it only records the last IP. Then the packet would then go to the next node and the next node and so on until it gets to your exit node. And so therefore it will always be different. And so in that sense, we would have more privacy in how our traffic is passed in TOR. Now you also have options to use Tails, which is the OS on a USB to make connection to TOR. So it would be like USB, and it would automatically connect. So it gives you the option to connect to TOR. Or on the Android device, you can use an app called Orbot. And this also allows you to connect your Android to TOR. So let's address the next few things. So in question 4, it asks you, how frequent does TOR change nodes to choose new nodes? I should say to allow selection of new nodes. And why? So every 10 minutes, it would change the nodes or add new nodes. Then it also, this is used to prevent traffic analysis. So somebody cannot scan you as a third party. Any question? Now for 5, how do you access Tor? You download the Tor browser bundle, unzip it, right? Install it. Then you would run the start Tor browser script. And it is included in the folder once you unzipped it. So the script is there, so you can run it. So how do you install and run Tor browser launcher on Debian? We talked about that. We simply use command line or terminal, and we would do a sudo apt install Tor browser launcher, and then we can call on the Tor browser launcher once it's downloaded and installed. So the look and feel of that will look like the Firefox, right? But it has additional options and it would connect to various services or hidden services, which are sites, onion sites. So the website that you see, it would use the .onion. Those are the sites that exist in Tor. So the browser itself is designed to access these websites, right? And also their identity where it's hosted is hidden. So you can't really identify like who hosts those sites, right? Therefore, in the dark web, it's really hard to identify, right, who's who. Now, why are we using this is because some of the tools that you might be using, right, or the things that you do might require you to investigate Tor. So we want to know how to do this. Any question regarding install, the process on how to use it? So part of the exercise today also is to allow you to install it on your Linux. So you can use Ubuntu or Cali, whichever that you have on hand. Okay, and if you don't have Cali, you can download their virtual machine from Cali website. And I wrote the instruction on how you can do that. You can import that into VirtualBox. So in some case, you might run into where internet service provider block, right, Tor traffic. Now, compared to other relay nodes, your bridge relay is not publicly listed. And these are systems that can also pass your traffic, but it is not publicly recognized. So in the case where if your traffic is blocked by ISP and you still want to access Tor, then you can use the bridge relay. And in the notes, it provides you with the link to be able to access the DB that contain bridge relay information. So for question 7, the purpose of bridge relay is to connect to Tor when you have blocked traffic from ISP. And the main difference between this and your normal relays is that bridge relay is not publicly listed in the directory. No public key. You might be So did you install it, Michelle? Okay. On your Linux? Okay, yeah, okay. Let's try that shortly. Started sudo app install. Okay, so you download it and install it, and when you call on the browser, it did not want to go. So I wrote some instruction. You need to make sure that you update it. And then you can also just install TOR instead of TOR launcher. You can do it either way. And then you want to also do a restart with the init.d for TOR, so it restart the service. Then once you have that, you can start the TOR service by doing the start command. So if you look at number 8, so in Cali and Ubuntu, it gives you the documentation very brief, right? Sometimes that requires additional components for it to work. So we want to make sure that we update it. And then if you can't get the TOR launcher to go, you can try to just use TOR and restart the service. It won't do the launcher browser, but it still connect you to TOR network. Okay, any question? Any other questions? So while you are looking at number 8, let me see if I can pull up my VirtualBox real quick. So I did download Cali, and I wrote down the instruction for you how to import Cali, okay, into your VirtualBox if you don't have Cali, or if you have Ubuntu or something like that that you've been using, you can. I'm going to use Ubuntu desktop right now, but you're welcome to use Cali if you have it. Well, I'm using the school network, so maybe I might get blocked. We'll see. Share screen again. Okay. So if you are if you want to use Cali, you can download this. It's about 3.6 gigs. It takes about 10 to 15 minutes, depending on how fast your network is or your bandwidth. In general, I did it today. It took about 15 minutes here, and I did it for my other class the other day at home, and it took only a few minutes. So if you don't have VirtualBox, you can download it and install it. So after you download from Cali, let me go to the site so you can see. The option you want is this one, right? As the other ones are for IoT and ISO and bare metal. So if once you click the virtual machine, you have 2 choices. So we are going to choose the VirtualBox one, and you just click this one unless you want to use torrent, which is, to me, I felt like that was slower when I tested downloading torrent the other day. So you can download this. So it's about 3.7. So once you download it, it is going to come down as a OVA file, which is which you need to use. It's like a compressed format of the virtual machine, so it doesn't have it has all the folders and everything within it. So what you need to do is you need to import it. Okay. So with that, once you have that, you would then, it's going to prompt you. So even if you double click it, right? It's going to ask you for VirtualBox, but I think it's best to open VirtualBox, click machine, and then click import. And then you just browse to your download folder and find your Cali VM file, which is OVA. It looks like an orange box. Then you're gonna have to accept the license, so you have to click agree. And then it's gonna unpack, and then it's gonna mount the virtual machine storage to your VirtualBox. Then you can click start. The default password and username is Cali, as some of you already know that. Okay. And then if you read their documentation, they have a section on TOR. So here, go to right. So let me update it real quick. I'm using Ubuntu. So when you run the updates, that might take a few minutes. Even if you use Cali 2022, it will require a few minutes to update. But always in Linux, we learn that we always update before we do everything else. And then we can use the next command after that. So we're going to do a sudo apt-get install TOR. And then we're going to say yes. So as it's installing TOR, then we are going to modify, or we're going to restart it with the initial, the initd. Okay. So I am completing, I just completed the installation. Size this down so I can show you that it's together. So now we would do a sudo etc init.d and TOR restart. Okay, so it restarted the service, and if you want to start the service again, start. So this is redundant H, right? Because you restarted here. Okay. Then we want to check our connection status. So we would say service TOR status. And here what you would see is it's going to give you the additional information. It tells you that it's started the anonymous overlay for the network. And then you have to go through the right to see more. Right. So we can scroll down to be able to read more information. So here is that we show that it is an active. Okay. And it loads your service from the TOR directory. Any question? And you also see here that your status is success. So that's what we want to screenshot. Any question? Okay, so after we have the status information, we would screenshot that for our assignment. Now, before we get into proxy chains, let's come back to the notes here. So in the node type section, it also identified the additional details as we talked about intermediate, which is the relay, your entry node, which is your guard relay, right? You have your middle nodes or your middle relay. So the intermediate nodes, they do not know where your traffic came from and where it's going to. And they also don't know where they are in the network because these are also randomly selected for your route. So if you click the link that's given here, you would see that there is a map that can be provided, right, for all the existing nodes inside for TOR. Okay. But because there are many, right, our combinations for our route will be different, even if we're visiting the same. Now, if you look at bridges, like we talked about bridges, you can identify, it gives you the list of the bridges here, and then also like the exit and so on. So some of these are also identified as bad. So if they're active and running, right, they will be selected in the route. Any question? So we would see that like for the majority, right, you would see that will be Europe. And then we would see for every continent and sometime out in the island, sometimes in different countries and so on. So coming back here, after that section, it talks about the bridge relay here, which we answered. They are not listed, but there are normal relays. Okay. So proxy chains, they're used to connect, right, numerous proxy together, and it uses 3 types of protocol: your HTTP or HTTPS, your SOC4, and your SOC5 protocols. So the way that it resolved the DNS is through the proxy. So earlier we mentioned that there are additional services that can be implemented to resolve DNS. And so we would use proxy chains to do that. And this makes it difficult for someone to really sniff out the traffic. So I have a typo here to the control port. Now there is a configuration file in TOR, and this is called the TORC file. And in this file, it specifies, right, the type of ports that uses, also the protocol. So as you can see here, so your SOC port, you can specify that. So the default that comes in this file, you would see that you can specify the port 9050 for the SOC traffic. So as it communicates, with the next node, it would use that port. For your control port, you can also use the port 9051. So in your configuration file, you can modify this file in how you want to use TOR. So when you're using SOC 9050, it waits for the connection, as we talked about socket in the past, right? So it is an abstract element that really listens for connection. The applications, they use that to be able to have the communication from one system to the next using a specific protocol and a port value or IP. So this port is going to listen and it's going to wait for connection from other applications. Then it's going to determine how it's going to use the proxy based on the connection. So when the machine would start the TOR service, it's going to obtain a directory from the server. Okay. And that's through what's called the non-encrypted link. So it's going to give you a list of the nodes in the TOR network. And a handshake would then be established with the directory server. And it's going to connect to the server. After that, once the network status is ready, it would authorize the connection through giving you a certificate for the key. Then subsequent to that, you would have what's called the exonera. So this is going to be a list of IP addresses in the TOR network. It's going to store at least one IP per relay, so one or more. And it's going to store information whether the node allows TOR traffic to go or not. So the screenshot that the author did was this one, and I captured it here, where you would see with the NICs. Okay. So with the NICs, sorry, I got scrolled up there. This is a way that we can gather real-time details with the bandwidth usage. So it shows the connection that has been established, and it uses the information or the configuration from TOR-C file. Very similar to what you see with netstat or top. So it shows who is it going to connect to, or which relay nodes it's connecting to. Any question with this? So once you had started the service, you can set up your proxy chains. Okay, and you would use proxy chains through Firefox, and then you would put in the domain. Then to configure your TOR-C file, you simply use TOR, make sure that this is a double dash, and then you specify the sock port as the control port, also double dash. Sorry, my Word application autocorrects. So make sure we use a double dash. So you can set your sock port 9050 as control port. And then once that's set up, just take a screenshot. So if you're using the TOR browser launcher, and if it's not working, it's maybe push the update first and then reinstall the browser launcher and then see if that will work for you. But you can simply do this. You can start the TOR service and that will activate. Now the browser allows you to visit various links or search. We'll talk about search engine too. So as we mentioned, that the last step was to be able to use the tools to gather some of the connection information, and the tools that you would use is NICs. Yeah, you know, because the packages, sometimes it requires certain files, and if you don't have that file, it throws an error. So we talked about how NICs is used in real-time connection and to get the information about real-time connection for your relays. And then for Exonera, that's just, it's stored the IP addresses of your node relays once that service started. Okay. So that's where you can go and get some information, are those two tools. Any question? So in TOR, we can use OSINT, which is your open source intelligence. And this is a set of tools that you can use to discover hidden services. Do we search our own info? Yes. You can use a search engine to do that, and I'm about to go over those, so you can use those. So when you subscribe to services, so my data has been leaked through T-Mobile, and they gave me a 1-year service with the company that actually, give me information if my data goes to the dark web, right? So all of that is that it uses this in order to gather some information about a certain individual. It could be your social security number and so on. So you start with your name. So your open source intelligence is just a suite of that contain different tools that you can use to discover information in TOR or discover hidden services like sites. Just like how you would use a normal engine, but your search engine, like Hidden Wiki, it looks for the onion sites along with the other. So you can use Hidden Wiki, and that would contain links to many hidden service. Okay. So unlike your regular wiki, this is anonymous browsing, so you will be able to browse or use wiki anonymously. The standard URL is provided there. And then if you want the TOR URL, it's here. Okay, I embed it to this. You can also use Torch, which is another search engine. This will allow you to find active onion site. And you can access it using this link. Another one would be your AMIA, or you can use dark search. So dark search is specifically for onion addresses. And you can also see, you can search what you would see in other web browser instead of just onion web browser. So that's a little different. Okay. And AMIA is the same. So the last two are a little bit more advanced than some of the others. So you would see different features as you would use some search engine in TOR. So you can use that to find where the data went, if they have your information, if, so you can search for your name or anything that would relate to you. But companies would do that for other things too, outside of just looking for data. Okay. Then part of your suite, your OSINT, your intelligence suite, you would see OnionOff. This is a tool that we can check status of the site before sending requests. So if we want to know if that is active, we can use OnionOff. And so the script, basically it uses request module library in Python, Beautiful Soup, and PySocks. So all of these are part of Python, right? So it's basically a Python script. So you would run it as a Python file, and then after you download it, and you would run the .py, and you can specify the options or the switch. And here we would output our report, right? And then we would input the URL. So you can check a certain, so we can do it as a group of URLs if you have a list in this text file, and then you want for it to check on every single URL and then give you the report in the report.txt. So we can do a group of URLs together that way using oniof or oniof, I should say. And it would look something like this. So it would inspect each of the onion or the site, and then it will tell you whether it's up or down or active or inactive. And it's simply just send a request, right? So when you create that list, it plugs those URL in as endpoint URL, and then it would just submit the request, like what we've seen in the last 2 weeks when we do HTTP programming. Any question with this? So we can also use onion scan, and this is going to allow us to monitor or track deep websites. So when you land a job that requires you to access the dark web in order to look at, or the deep web in order to look at some of the information about the organization or people, right? You can use some of these tools. You can use it to also find information on yourself. So onion scan, it allows you to monitor and track sites. And it also tells you what type of vulnerability in the privacy and the level of anonymity that is. No. Where does the URL come from? So they have to register these sites to the Onion network. And when they register these sites, just like your normal website, you get this domain information, right? Like the URL that you see is what they are publicly registered as in TOR. Okay, so the server that hosts these sites could be anywhere in the world. Okay, that this is their public domain information, and it uses .onion because it's part of the TOR. Unlike your regular site. So it only exists in TOR. Now scan is written in Golang and Go, so someone can buy the site. Yeah. Well, someone can buy that or use it. If it doesn't belong to people, right? So sites that, let's say that you might have sites that sell illegal drugs online, right? And that would have a specific URL, and the crawler or your search engine would in TOR would be able to do that, just like how we would use Google to search for a certain website in the regular internet, right? So you would use a search engine to look for a certain topic, a certain type of site, right? Category of sites and so on. And these are registered to the TOR network. So as we were saying, Onion Scan is written in Golang, and it also uses, you can implement SOCKS proxy for connection. And so here gives you the details on the source code for Onion Scan. We can use it to detect web server that are in use and websites. We can also check if there are vulnerability in their settings for privacy. That's important. Also, we can extract metadata and do server fingerprint and extract. So it does a little bit more than just, giving you website information. It is a scan against the web server. So it tells you the details in the type of services that you use, like SSH, FTP, SMTP, and also the metadata that exists on that web server and its fingerprint. And like many of the security tools, you can complement this tool with, you can use Onion with Nmap. And that uses the Docker. So Docker container allows you to scan hidden services in TOR network via Nmap. So it uses the DNS mask queue, Proxy chains, and Nmap to scan. So as you know, the Nmap is invasive. Okay. But in TOR network, because of we can do this anonymously, it does not trace well. So in that sense, you can't scan. And if you want to run things separately, and like what we have been talking about, these things are best in Linux or Linux-based system. Right? If some of you have Mac OS, since you're using terminal, you might be able to run the resources, but I would run it on the virtual machine or something that you don't regularly use. Okay, question. Okay, so the last part for our assignment, we just have to answer a few things. So you can pick any of the search engines that are listed in the notes, and of course there are more, but those are the common one that you would see in TOR. And I picked Amia and Dark Search because they are a little bit more, it has a little bit more advanced feature, but you can list Torch or the wiki. The purpose of OnYoff is to really identify active hidden services or active websites in TOR before submitting the request. So that way we know which one that we should put the effort into submitting requests with. And you can create a list of URLs. And the tool that is used to monitor and track websites in the dark web or the deep web to make sure that it's anonymous or has vulnerability or not, it's going to be your Onion Scan, as we said. And then lastly, we touch on how we can use Docker, Onion, and Nmap, which allows us to scan for hidden services in Nmap. So the lab for this week is going to be with Python. And of course, we are going to use Linux because we have to run TOR service in the back in order to scan. So, if you don't have Linux machine going, make sure that you get that ready by Wednesday. And if you complete question exercise 8, you should have it ready. Okay. And you can use any of the Debian or any of the release. You don't have to use Cali. So you can use Ubuntu if you have it. Okay. Any questions? So I think the assignment really show you how you can use Tor, what kind of features and things you can use Tor with, and how it works. So that way you can understand. Because a lot of people always talk about, Tor and what they are, but I think, understanding the technicality in Tor is important because it encompasses a network that contains a lot of information that we might need in this field. Okay. And there are different tutorials and things available for Tor as well. And you can also look at their project link. Any question? See the chat comment. Do I disable or stop Tor? Yes, you can. Just stop the service. But as you end the session, right, it just terminates everything. So you can always restart it. Yeah, you can terminate the service and then you can power off your machine if you're done with your assignment. Because, even we're using a virtual machine is also vulnerable to attacks as well. They can do escape, and so, but we always want to turn things off when we don't use it. Okay, I'm gonna stop recording so that way it's not super long.